Okay, so this is the bonus problem for exam number 1 for dynamics this semester. And so we see we have a football player, and this football player is throwing a ball and he's releasing it at an angle of 60 degrees at a speed of 20 meters per second. And we have the receiver here that is 15 meters away. And we want to understand two things. We want to calculate, where does it start? It says determine the constant speed at which player B must be running so that he can catch the football at the same elevation at which it was thrown. Also calculate the relative acceleration of the football with respect to B at the instant the catch is made. And so what we need to first determine is where does the ball come back to the height in which it was thrown? At what X location is that? So let's start. Let's move over to our paper here. And so first let's draw a little diagram here just for reference. So we got our football player. That's a great picture, by the way. And we have our football and it's launched here. All right, let's move our football up here. It's launched here at 60 degrees. And we have our other guy here. He is 15 meters away, and the ball is going to go way up here, and he's going to catch it down there at some point. Okay, so with respect to our equations in the X direction, we have, let's do this over here. We have X equals X naught plus V naught in the X direction times T. And we also have Y equals Y naught plus V naught in the Y direction times T minus 1/2, and let's go ahead and call this GT squared. So by default it'll be plus 1/2 AT squared, but we know this is projectile motion, so it's acceleration due to gravity. Okay, so those are our two equations. So from the beginning we can establish that for the X equation we can say that X at any point would be equal to 20, which is the initial velocity at 20 meters per second, times the cosine of 60 degrees times t. Okay, because we know that x naught is 0 and y naught is 0 because that's where we establish as our origin. So once we have that, we know that cosine of 60 is 1/2, and so x would be equal to 10t. Okay. Similarly, we can do the same thing for y, and we can establish that y is equal to 20 sine of 60 degrees times t minus 1/2 9.81 times t squared. And what we know is we're looking for the point where the ball reaches back to the origin with respect to y, so we'll set all this equal to 0. So y is 0 in that instance. And so what we have here is a quadratic equation in t. So if we wrote out the quadratic equation, we would have negative 4.905 t squared, and that's working all the math out, plus 17.32 t equals 0. And so if you use your quadratic equation that we're very familiar with, which is negative b plus or minus the square root of b squared minus 4ac over the quantity 2a, then we can solve that quadratic equation. So for the sake of time, we're going to just say that when we solve that, we get two answers. We have t equals either 0 or 3.53 seconds. And so the one that we're looking for is actually the 3.53 seconds because the 0 is the origin where the ball is thrown. And so now that we have this time, we can go back to our equation with respect to x and figure out where the ball actually needs to be caught. So let's call that point out here. We'll call that B. And so we can say that x of b, so this is the same equation over here, is equal to 10 times t. And we know that t is now 3.53 seconds. So after 3.53 seconds, we know that xb would then be 35.3 meters. okay? And since we know that x of b is 35.3 meters, now we have to figure out what is the velocity that the player would have to run to be there in 3.53 seconds. So when you think about that, we're really just talking about the amount of distance divided by the amount of time. And so he would have to go, a distance would be 35.3 minus 15 meters in a time period of 3.53 seconds. So this is meters and that's seconds. And so our answer would be 5.75 meters per second. So V of B, which is the velocity of our runner, would be equal to 5.75 meters per second. So that's the first part of this problem. The second part is we want to know what is the relative acceleration of the football with respect to the player. And so our football we'll call C. And so that relative acceleration equation would be A of C is equal to A of B plus A of C with respect to B. Okay? And so if we look at this, the acceleration of B is 0 because the problem tells us that the velocity of B would be constant. Okay? So we know this is 0. And we know the acceleration of C. The acceleration of C is 0 in the x direction, but only negative g or g downwards in the y direction because that's the acceleration due to gravity of the football, right? And so we'd say that A of C is 9.81 in the negative j direction is equal to 0 plus A of C with respect to B. So that's simple. So A of C with respect to B would be equal to negative 9.81 J. So that would be the value of our relative acceleration of C with respect to B. And let's make sure we include our units there. So that's meters per second squared. So that is the solution of, sorry, I got this chopped off a little bit. That is the solution of our bonus problem on exam 1.